Hello and welcome to the Classroom Professor Math Podcast. This program is designed to help you to prepare and teach mathematics more easily, efficiently and effectively, to truly engage your students in mathematical thinking and to develop their numeracy.
G'day everyone. I am now in Scotland on what is probably a fairly typical Scottish day. We've had lovely sunny weather everywhere we've been for the last 3 weeks, but today it's raining and it's jolly cold and it's misty. So there we are, this is Scotland. And behind me you can see 3 wind turbines which make up a small wind farm. Now the vanes were turning when we got here. They might slightly, I don't think they're turning at all now, so they've stopped because the wind isn't blowing, and that of course is a problem. Just want to talk briefly about the generation of electricity and wind power and then connect it with the study of the environment in the classroom. And this rain's getting heavier, so I'll be reasonably quick. To generate electricity, there are several methods that we are currently using. There are quite a number of different options. Most of them involved the principle that was discovered, I'm estimating, some 150 years ago, which is that if you move a wire in a magnetic field, electricity flows in the wire. It's a brilliantly simple idea. You can demonstrate it in the classroom. So if you can use energy to rotate something, and the faster and stronger the better, of course, and connect that to large coils of wire and very strong magnets around the outside, you'll get a wonderful flow of electricity in the wire. So that's what's used in hydroelectric schemes. The water pushes a turbine, or anything where you can heat water, so geothermal, coal burning, gas-fired, nuclear, any of those. They heat water to make steam, push the steam around a turbine. That's how it works. And of course with the wind pushes the vane on the, I don't know what the thing's called, but what most of us would call a windmill. Rotate that, the electricity is produced. Obviously, if the wind doesn't blow, you don't get electricity. And so the electricity generation authorities and the companies that are involved in these processes have to have some sort of backup plan for generating power when the wind doesn't blow. A recent comment made in the British press, I read an article that mentioned this, by someone in authority in this sort of area, I think he might have been a politician, said we will simply have to get used to not always having electricity, so if the wind doesn't blow, we just won't have any electricity. Personally, I don't think that's a practical plan. I don't suppose many people actually agree with him. So there are really important questions to be raised, and the fact that these are not turning illustrates the biggest problem for wind. If we could have continuous strong wind all day, all night, that would be brilliant. If we had a continuous supply of wind, we could switch the generation on and off when we needed to, but in reality life's not like that. So before spending millions and billions of pounds in Britain on renewable sources of energy with onshore and offshore wind farms and multitudes of other ways to generate power in this country, very, very important decisions have had to be made. People have had to collect some really hard data and not just guess and not just estimate. So, well, it seems pretty windy here, let's put up a wind turbine. Obviously you have to measure how much wind you get, how often it blows, how strong, etc., etc. How much power will it generate, and what do you do when the wind stops? I looked up some statistics this morning, and the average, I forget the words they use, but the amount of power that is generated compared to the amount that would be if it worked at full power continuously. For wind generation, the percentage is about 25. give or take. It's down a bit in 2007, up a bit in 2009, whatever. So around about a quarter of the energy you could get if the wind blew continuously. So all these statistics have to be gathered, they have to be analysed by people in order to make decisions. So let's connect this with the classroom. In many places, students are learning about the environment. It's an important topic for everybody nowadays, something we all have to be aware of. And obviously students, when they are adults, we as a community want them to be environmentally aware, to recycle rubbish, to reduce their use of electricity, and so on and so on. And of course they'll be voting when there are decisions to be made, and there are elections for politicians and so on. We as adults effectively have to have an opinion, or at least we're asked what do we think about the decisions that pollies make. So with our students, let me encourage you, this is my encouragement today, in studying an environmental issue and inviting and encouraging students to be involved in it and possibly actively involved in it, recycling rubbish, being aware of what's happening in the local community, possibly writing letters to the local authority, the local council, or a local newspaper. Any sort of activity involving these decisions, which can be really controversial. They often are. It always has an impact on somebody else. You can't just say, I know, let's put up a wind farm. This farmer here has got wind farms on his property. He might not like that. So there's decisions to make. Any of those sorts of studies that you might do with your students should be based on hard data. Just as the big decisions about where to put wind farms, you need to collect the data. I suggest that in the classroom you similarly need to make sure that data is collected. That's good data, it's based on solid facts, and that you encourage your students to see the use of mathematics to help address these really, really important issues. So you can have them collecting data. There are all sorts of issues that students can be involved in, even from a young age. You could look at the patterns of rubbish disposal in the school. How many pieces of litter are there? How many children actually put them in the bin? And how, all sorts of things you could do. You could survey people, you can go and collect observational data and so on. But this is a really, really fantastic use of mathematics, something that really, get students' teeth into and connect the maths with something that you will have, encouraged them to see as really important. And I'll leave that with you, and I'll see you next time.
Thank you for joining me on the Classroom Professor Math podcast. You can email me via peter@classroomprofessor.com or follow me on Twitter with the username peter_price. You can also visit our website at www.classroomprofessor.com to download free resources, including the ebook 10 Minutes a Day Times Tables Worksheets. If you have enjoyed this podcast, please go and rate the show on iTunes. I look forward to speaking with you next time, and until then, goodbye.